Hi everybody, this is our supplemental video for naming monocyclic and bicyclic ring systems. The IUPAC rules for naming monocyclic rings are really straightforward, so we'll begin there. The first thing you want to do is identify the ring, count the number of carbons in the ring system, and identify that immediately as your parent system. Then what you want to do is identify your substituents coming off the ring system and number the rings so that the substituent with the lowest priority is at carbon number 1. That is, you want to pick the substituent with the lowest alphabetical position and put that at position 1. Lastly, you want to minimize numbering around the ring, similarly to simple alkane systems. So let's take a look at the example below. If we look at it, the parent in this case is a 6-carbon ring, so it would be a hexane ring system. And then we would want to identify the substituents coming off the ring. Up here we have a methyl. And then down here we have an ethyl. You can tell alphabetically E comes before M. So we want to number our ring starting at the ethyl position. And then we want to go around in either direction so that we have the methyl at the 4 position. You can tell it doesn't matter whether or not we're numbering counterclockwise or clockwise in this example because methyl will always come off of position 4. Now what we want to do is put the name together, so the ethyl is coming off the 1 position. We'll say 1 ethyl, and then 4 methyl. And then last but not least, we need to identify it as a ring system, so we want to call this methyl cyclohexane. It's really important that you identify it as a ring system by putting in that cyclo prefix before the hexane. Alright, so those are pretty straightforward. The big difference now is what happens if you have 2 ring systems that are fused together. These follow a different set of rules, but again, it's fairly systematic. The first thing you want to do is count all the carbons that are in all of the ring systems. You don't count any of the substituents coming off of the rings, but anything that is participating in a ring is counted. Next, you'll have this bracket with 3 numbers in it. I'll explain what that means a little later on in the context of some examples, but these identify how long the bridge lengths are between bridge heads. And then lastly, you want to number your ring system so that the numbering starts at 1 bridge head. You go around the largest ring first, then you go around the second largest ring, and then lastly you go across the smallest ring system. So let's see this in the context of some examples. So here we've got a bicyclic ring system. First thing I do is I identify the number of carbons in the ring system. So in this case it looks like we've got 7 total carbons. So this would be a heptane. In this case, we're not going to put cyclo in front of it because we're going to use the bridge head indicators in brackets like you saw above. So after I identify the total number of carbons in the ring system, I then mark my bridge heads. I like to use red pen, so I've got a bridge head here and here. And then next, what I want to do is identify the path length it takes to get from one bridge head to another. So for example, if I follow this blue pathway, this blue pathway goes over 2 carbons, so it's a 2-carbon bridge. If I look at this pathway shown in orange, this is also a 2-carbon path from one bridge head to the other. And then if I identify this remaining bridge pathway, you can tell that this is a 1-carbon bridge going from one of the bridge heads to another. So what you want to do is arrange these in order from largest to smallest and put that in brackets. So for example, this would be a 2, 2, 1. And then in front of it, what you want to include is a bicyclo to help clarify that the brackets in this case are referring to the bridge heads for a bicyclic ring system. So this molecule would be named bicyclo 2,2,1 heptane. Let's take a look at another example. This one, again, we want to first identify the total number of carbons in the ring system. So you can tell the ring on the left is 6 carbons, and then there's 3 carbons attached. So this would be a nonane. And then, same sort of system, we want to identify 2 bridge heads. This bridge I'll label in blue, takes 4 carbons to pass through. If we do the bridge over on this side, this is now a 3-carbon bridge. And then last but not least, we've got this linkage between 2 bridge heads. And this throws people off because they say there's no carbon linking them. But it is okay to have a 0 path length bridge, right? In this case, there's no carbons. So let's fill that in the brackets from largest to smallest. This would be 4.3.0. And again, we want to put in that bicyclo in the beginning to indicate that it's a fused ring system. So this would be bicyclo 430 no name. All right, let's do another one down below. Again, we want to identify the total number of carbons in the ring system. So this would be 8 carbons. So this would be an octane. We want to fill in the brackets here. So let's identify our longest carbon going from this red bridgehead to this red bridgehead. And in this case, it doesn't really matter which one you pick. You've got a 2-carbon bridge on this side, or you've got a 2-carbon bridge on that side. I'm going to actually give this a little bit of perspective. And then we also have this 2-carbon bridge going up here. So in this case, we've got a 2.2.2 octane, and again we want to put bicyclo in the front to indicate that it's a fused ring system. So this would be bicyclo 222 octane. All right. Now the question is, what do we do if we have some substituents coming off a fused ring system? We still want to follow the same system, but we need to be a little bit more careful with how we number the ring system. So let's look at this first one. Again, if we look at the carbons included in the ring system, we've got 6. So this would be a hexane. We'll put the brackets in front. And in this case, we've got a bridgehead right here, a bridgehead right here. We can have a path length over here that's a 2-carbon path length. We can have a bridgehead over here that again is a 2-carbon path length. And then the one in the middle, we don't have any carbons linking them together, so this would be a 0-carbon bridge. So again, if we put these in order, it would be 2, 2, 0 hexane. All right. Again, we want to put bicyclo in front. But now we need to identify that bromine and identify which position it comes off of. The first thing you need to do is number so that a bridgehead is always at position 1. So I'm going to pick this bridgehead. And then what you want to do is number going around the largest bridge. In this case, we've got a tie between 2 and 2, but we want that bromine to be at the lowest possible position. So I'm going to go around that orange bridgehead. So I'll go 1, 2, 3, 4, 5, 6. So it looks like our bromine is coming off the 2. So this would be 2 bromo bicyclo 220 hexane. All right, let's try this more challenging one down below. All right, so let's look at this next ring system. The first thing we want to do is identify all of the carbons that are in the ring system. So if we count them, I've got 1 carbon here, 1 here, 1 here, 1 here, 1 here, 1 here, 1 here, and 1 here. We do not count the exterior carbon because it's not in the ring system. So in this case, we've got 8 total carbons that are participating in a ring system. So this would be an octane. Again, we want to put in brackets to indicate the bridge lengths. So I'm going to erase these dots just so we don't get confused. And we've got a bridgehead right here and a bridgehead right here. You can see we've got this bridge going along this blue pathway. And this blue bridge, if we count, has a 3-carbon bridge length. If we go along the next pathway, I'll label this one in orange. This has a 2-carbon path length. And then the green one right here is a 1-carbon bridge. So this would be a 3,2,1 octane. And again, we want to put bicyclo in front. Okay, but now we need to number it so that we've got our substituents in the correct position. All right, so again, we want to number at our bridgehead. So in this case, I'm going to number this bridgehead number 1. So if this is number 1, we want to go around the longest bridge first. In this case, 3 is longer than 2, so I'm going to go along the blue pathway. So I go 1, 2, 3, 4, and then 5. Now I'm at the second bridgehead. Now what I want to do is keep on following that pathway around the second longest bridge. So I go 6, 7. I'd skip number 1 because that's already got a position, and then put the number 8 up at top. So now if we look at it, the chlorine is coming off of position 8. So we've got an 8 chloro. And then off of carbon 6, we have a methyl group. So it'd be 6 methyl. So now the question is, which one goes first? And again, you want to alphabetize them. So 8 chloro should actually go first. I'll put that in the front. And then I'll put the 6 methyl in between. Oh, let me slide this all around. And I'll put a dash in there to indicate that they're all in the same system. So this would be 8 chloro, 6 methyl, bicyclo, 3,2,1 octane. All right, I hope that helps you guys. Make sure that you study in a group when you're working through these. Oftentimes your partner will catch mistakes that you don't see the first go around. All right, good luck.